All right, hi guys. We're looking at one of our worksheets that we said that we were going to try and identify our types of chemical reactions, okay? And what I'm going to do is I'm actually going to come look down here at these last two chemical reactions, right? And if we look at these two, they don't really fit any of our four types of chemical reactions that we've talked about so far, right? This one, it's not really a synthesis reaction. It's not really a single replacement, double replacement, any of that. So these two reactions are actually combustion, okay? These are combustion reactions. And in a combustion reaction, we oftentimes are going to produce water, actually, okay? So we're going to produce water, and in this case, carbon dioxide, okay? Whoops, CO2. So in our first case, right, we've got nitrogen. In a combustion reaction, when nitrogen reacts in a combustion reaction, it produces NO, okay? This is a nitrogen oxide, right? And in a combustion reaction where carbon is involved, we produce CO2, okay? So oftentimes when we have combustion reactions, we always know that we create water and some sort of oxide. Generally, it's going to be carbon dioxide, okay? So this is our last type of chemical reaction. We should have 5 types of chemical reactions, okay? Our next step was to start balancing our reactions, okay? So what I'm going to do is I'm going to go back to our notes, okay? And in our notes, right, let's talk about our chemical equations here, okay? So our chemical equations, right, this is a set of symbols that state the reactants and products in a chemical reaction, okay? So reactants are the starting substances in a chemical reaction. It's found on the left side of the arrow, okay? The products are the substances that are produced in the chemical reaction, right? It's on the right side of the arrow, okay? So here's an example where we have Na and H2O forming NaOH and H2. This would be a, looks to me like sodium is kicking off a hydrogen. That would be a single replacement reaction, I would say, right? And what we can see, right, our chemical reaction here has some numbers before it, right? These coefficients make our overall reaction to be balanced, okay? Chemical equations must be balanced, right? We can think of our arrow kind of as an equal sign, right? Our two NAs, our two H2s, and our two oxygens are balanced out on the right side by two NAs, two oxygens, 2 times hydrogen, that's 2, plus 2 more, that's 4 oxygens, that matches, okay? So our number of each element matches on the left side and the right side because our law of conservation of mass, right? Mass can neither be created nor destroyed in a chemical reaction, okay? So balancing our equations, right? The number of atoms of each element on the reactant side of the equation must be the same as the number of atoms of each element on the product side, the right-hand side of the equation. Okay? So the coefficients and subscripts tell us how many moles we have for each element, right? The number of moles or the number of atoms. So let's look at a balanced equation here, right? We have carbon plus O2, right? Oxygen is one of our diatomic elements, forming CO2. We have one carbon, one carbon. One O2 molecule, so that's 2 oxygen atoms, and we have 2 oxygen atoms over on our right-hand side, right? 1 mole of carbon, 2 moles of oxygen on each side of the arrow. That's what it means to be balanced, okay? So let's look at an unbalanced equation, right? And how we can see that it is unbalanced. What we have here, we have H2 and O2 going to H2O, right? H2 and O2 are going to be a diatomic element, okay? Right? And we look at this and we say, well, there's 2 hydrogens there, 2 hydrogens there, 2 oxygens there, only 1 oxygen on the right-hand side. So in this equation, oxygen would have to be lost, right? We would have to lose an oxygen atom. There's 1 less on the product side. That is not balanced, okay? So the coefficients, that's the integer in front of an element or compound which indicates the number of moles or atoms present, okay? The subscript is the integer to the right, the lower right of an element, which indicates the number of atoms, okay? So the compounds are the individual reactants and products in the reaction, right? We use subscripts, whoops, not subscripts, we never use subscripts, sorry. We use coefficients to balance the equation, right? Because our subscripts make sure that we have an uncharged chemical compound. Once we have an uncharged chemical compound, we can't change it anymore because that would change the charge, right? So we have to create our compound, make it uncharged with our subscripts, and then we are going to balance with our coefficients, okay? So if we look at this, right, here's another example. We have 2 silver molecules, 1 sulfur atom, forming Ag2S, right? So our coefficients on the left-hand side, 2 for silver, 1 for sulfur, and 1 for Ag2S. So we have 2 silver, 1 sulfur, 2 silver, 1 sulfur. If we look at our subscripts now, right, we basically have a 1 for both silver and sulfur, right, 1 of each. For Ag2S, we have 2 silvers there and 1 sulfur. But if we remember, right, Ag is always going to be a +1 charge. And sulfur, we look, it's in the 16th column, so it is going to become a -2 charge. So -2 and a +1, we would have to have Ag2S to have an uncharged compound. So that's going to be our uncharged compound. We're going to start with silver and we're going to start with sulfur. Then we have to look at our coefficients to balance our equation. To balance the equation, we know that we've got 2 silver, so we need 2 silver on the left-hand side. We've got 1 sulfur there, so we need a 1 sulfur on the left-hand side, okay? So our next video is going to show us one way to balance our equations.